This is part 3 of the series Parallel and Perpendicular Lines. In the last part, we went through the 4 postulates and theorems related to parallel lines and transversals. And we talked about the corresponding angles postulate. I'm going to begin this session with a proof of the alternate interior angles theorem. And that's going to use the corresponding angles postulate. And we're going to look at the alternate interior angles theorem, and you'll see that the alternate exterior angles theorem proof is almost identical to this proof. So we're only going to work the alternate interior angles theorem proof, and then we're going to move on to the consecutive angles theorem proof, because that one's a little bit different than these. So we're going to do 2 proofs for these, and you should be able to glean the ideas from the other theorems from these 2. So let's start off. Like with any proof, we have to absorb our information given. So we have line L is parallel to line M. And I've written in here angle 1 and angle 2 because we're trying to prove that angle 1 is congruent to angle 2 given that line L is parallel to line M. Now I'm going to add one additional piece of information here, because the plan for my proof is going to be I want to use the corresponding angles postulate. Now, one way that I can use corresponding angles is to notice these 2 angles are vertical angles. Remember we talked about vertical angles and linear pairs? Well, these 2 angles are vertical angles, so that means this angle and this one are congruent. And if you notice, this angle and this angle are corresponding angles. So I'm going to go ahead and put in angle 3 up here so that we can use this in our proof. So that's angle 3. All right. So now that I know that these 2 angles are congruent and these are corresponding, the corresponding angles postulate tells me that these 2 are congruent. So I should be able to set up a relationship there between angle 1, angle 3, and angle 2. So that's the general overall plan for the proof. Let's get started and write down our givens. And we said we want to use the fact that these are vertical angles and that vertical angles are congruent. So that's what we're going to write next. We're going to say that angle 1 is vertical to angle 3, and therefore that angle 1 is congruent to angle 3. And so we say angle 1 and angle 3 are vertical, and that's the definition of vertical angles: 2 non-adjacent angles whose sides form 2 pairs of opposite rays. And then we can say that angle 1 is congruent to angle 3. That's the vertical angle congruence theorem. So angle 1 is congruent to angle 3. Now that's all we have to say is that angle 3 is congruent to angle 2, and we can do that because those are corresponding angles. I want to make a special note here about the level of detail that you need to get in a proof. In most cases, it's really not going to be necessary to make statements like this. You're not going to have to identify that angle 1 is vertical to angle 3. We're going to look at those and we're going to say, yes, those are vertical angles. What we do have to identify is what's the consequence of that. So when we're dealing with this, we do have to write this statement here. It's not improper to write this statement, but it's not entirely necessary. It's okay to leave this off. Just like we don't need to say that angle 2 corresponds to angle 3. It's just an obvious fact that these 2 are corresponding angles. We do have to put down what the consequence is of that they're congruent, but we don't necessarily have to identify that these 2 are corresponding angles. Therefore, from this point forward, I'm just going to dispense with those little bitty details and focus on the pertinent details that are required to make this proof work. So here we go. Angle 2 is congruent to angle 3, and that is the corresponding angles postulate. Now, remember, we have to get to the statement angle 1 is congruent to angle 2. Here we have angle 1 is congruent to angle 3, and angle 3 is congruent to angle 2. Now hopefully you can see this pattern This is a recurring pattern that we've seen in almost every one of our proofs. If A is congruent to B and B is congruent to C, then angle A is congruent to angle C. This is transitive property. In this case, this is the transitive property of congruent angles. Remember, we have several of them, and we're going to actually end up with 5 different transitive properties. So we need to distinguish the difference. So we're going to say angle 1 is congruent to angle 2, and that's going to be the transitive property of angle congruence. So angle 1 is congruent to angle 2, transitive property of angle congruence. And that's our proof. We have just shown that given 2 parallel lines cut by a transversal, that the alternate interior angle pairs are going to be congruent. Now if you take a look at the alternate exterior theorem, the alternate exterior angle theorem is almost the same. The difference is this would be angle 1, this would be angle 2, and we would just pick the other opposite angle as angle 3, and we would still have corresponding angles and then the transitive property here. So the only thing that changes is where these angles are positioned, but everything else is fundamentally the same. So the proof is almost identical for alternate exterior angles. Now let's go ahead and take a look at the consecutive interior angles theorem. That's going to be a little bit different. In this picture, we have line L is parallel to line M, given by these 2 little arrowheads here, and it's given here. And we're going to try and prove that angle 1 is supplementary to angle 2. Now, to generate this proof, let's work backward from this position here. We know that these 2 angles are supplementary. Therefore, we're going to have to show that these 2 angles add up to, the measures of those angles add up to 180 degrees. Well, I don't have enough information in this picture to do that. So what I'm going to do is I'm going to add an angle up here, because I want to use the idea that this angle and this angle are supplementary, because these 2 angles are going to be a linear pair. And so if I can show that this angle is supplementary to this, and then because this angle and this one are corresponding angles, those angles are going to be congruent, then clearly if this is supplementary to this, then and this is congruent to this, then this must be supplementary to that. And that would be the congruent supplements theorem. So again, remember, when we're working with these proofs, everything you do over here is driven from this side. Now, you may not be able to see what I've just said over here, but just think of what the picture tells you. So I'm looking at this from the standpoint, I see that this says that I have to show that these 2 angles are supplementary, which means they have to add up to 180. Somehow I'm going to have to do that. And the way I'm going to do that is to create something else that adds up to 180. That's this angle and this angle. So I'm going to go ahead and write in angle 3 here. And now I can say that angle 1 is going to be supplementary to angle 3 because they're a linear pair. And so let's begin by putting in our given and move through with this proof. So now I've got my given down, and the next thing, I have to show that these are supplementary. Now, as I stated in the last proof, it's not necessary for us to sit and say angle 1 and angle 3 are a linear pair. You could do that. It's a matter of style. Angle 1 and angle 3 are a linear pair. And in actuality, it just kind of depends on how I'm feeling that day. Sometimes I write it and sometimes I don't. It's really not necessary. What is necessary is the consequence of that. We know that if angle 1 and angle 3 are a linear pair, then we know that this is supplementary to that. That is necessary, and that's the linear pair postulate that tells us that. So now we know angle 1 is supplementary to angle 3 because of the linear pair postulate. Linear pairs are supplementary. As I've said before, you're not always going to have a clear picture in your head of your path through a particular proof. You're going to need to use the information given and the things you can glean from the discovery of the picture and the information that you add to follow your way through the proof. using your knowledge of definitions, postulates, and theorems to guide you through. In this particular case, we started with two parallel lines, and we ended up saying that angle 1 is a linear pair to angle 3, and therefore they're supplementary. So we ask ourselves, what does that tell us? Well, if angle 1 is supplementary to angle 3, then their measures have to add up to 180 degrees. So that should be our next statement. To say, what does this say to us? Let's write that down. Is it going to be useful? Who knows? But I believe it's going to be, simply because we need to show that these two angles add up to 180 degrees, and we're going to eventually need to show that these two angles add up to 180 degrees. So it seems like a logical extension. So that's how you have to work your way through these proofs. And we know that this and this add up to 180 because of the definition of supplementary angles. So this reason drives our next statement. So the statement is the measure of angle 1 plus the measure of angle 3 equals 180 degrees. That's the definition of supplementary angles. Now, we have to get a linkage between angle 1 and angle 2. And clearly, angle 3 is going to be the key, because angle 1 is related to 3 because they're a linear pair. Angle 3 is related to angle 2. And why? Because they're corresponding angles, and corresponding angles are congruent when two parallel lines are cut by a transversal. So our next logical statement then is that angle 2 is congruent to angle 3. That creates the linkage to get us from angle 1 plus angle 3 is 180 to angle 1 plus angle 2 is equal to 180. So we're going to say angle 2 is congruent to angle 3, and the reason is going to be corresponding angles postulate. So our next logical step is, what does this tell us? Well, if angle 2 is congruent to angle 3, then we know that the measure of angle 2 is equal to the measure of angle 3. Because we know that because of the definition of congruent angles. So because the definition of congruent angles is that angle 2 is equal to the measure of angle 3. Again, why did I do this? Well, because I had to get to the point where I could say that the measure of angle 1 plus the measure of angle 2 is 180, because ultimately I need to say that angle 1 is supplementary to angle 2. So I'm trying to substitute this 3 with this 2. And now I'm in a position to do that, aren't I? Because I've said the measure of angle 1 plus the measure of angle 3 is 180 degrees, and I've said the measure of angle 2 is equal to the measure of angle 3, because I have to get to this statement, which means I have to replace this 3 with the 2, I can now do that because I can substitute the 2 for the 3. So that's my next statement. And because I replaced only one value, it's not transitive, it's just the substitution property of equality. And there's only one substitution property. It's just the substitution property of equality. Now I'm one step away, because I've said the measure of angle 1 plus the measure of angle 2 is 180. What does that tell us? What does it mean if the sum of the measures of two angles is equal to 180? What that means is it means that those angles are supplementary. That's the definition of supplementary angles. So I can now say angle 1 is supplementary to angle 2 because of the definition of supplementary angles. And there's our proof. Now, you could have come up with a different proof. You could have had a different order to these steps. But the important thing to note is you start with a certain set of information and ask yourself questions. And based on your knowledge of the definitions, postulates, and theorems that you've covered and studied, what does that information tell you? And that's the key to proof. Constantly asking yourself, what does this tell me? And what am I supposed to get to? If your answer to that question, what does this tell me, is I don't know, then that's a key tip-off that you really need to study your definitions, your postulates, and your theorems, because these will drive everything that appears on this side. In the next session, we're going to go ahead and use these theorems to solve some problems. So I'll talk to you in the next session.